Section 7.1, 0 and negative exponents. 0 is an exponent. For every non-zero number, a to the 0 power equals 1. So anytime you have a number or a variable with an exponent of 0, it is automatically going to equal 1. Negative exponents. For every non-zero number a and integer n, a to the negative nth power is going to be equal to 1 over a to the nth. So anytime you have something to a negative exponent, in order to get rid of the negative exponent, you move it below or across the fraction bar. So if it's in the numerator, you move it to the denominator. If it's in the denominator, you move it to the numerator. And then remember, in terms of exponents, the number for which the exponent is applied to is called the base, and the small number in the right-hand corner is called your exponent. So we're looking to simplify these problems. So 4 to the negative third power. Well, we don't want a negative exponent, so we move the 4 underneath and we change the exponent to a positive 3. The move changes the exponent from negative to positive. And then if we want, we can simplify this a little farther. So we get 1 over, well, 4 to the third is 64. And so this is our answer. Here we have 7 to the 0 power. Anything to the 0 power is automatically 1. Here we have negative 5 in parentheses to the negative fourth power. To get rid of the negative exponent, we move the negative 5 underneath, and we change it to a positive 4. Now we're going to figure out the negative 5 to the fourth power. Remember to use your parentheses, and you should get 1 over 625. And then last but not least, we get negative 5 to the negative fourth power. This time, the negative is not actually included with the 5, so we'll just leave it out in front, and we get 1 over 5 to the fourth power. We can simplify this, and we get a negative 1 over 625. In negative 5, or parentheses negative 5 to the negative fourth power, the base is negative because the negative sign is inside the parentheses. In negative 5 to the negative fourth, the base is 5 is positive. So unless you have parentheses around it, the 5 is our base and the negative is not, so it won't be taken with the 5. But if there are parentheses around the number, then the negative comes with it. All right, let's try a few more. 10 to the negative fourth, we want to make this a positive. Want to make this a positive exponent, so we put 1 over 10 to the fourth. Well, in this case, that'll simplify down to 1 over 10,000. Next one, we've got negative 2 to the negative fourth power. That gives us 1 over negative 2 to the fourth power. We can simplify this. We get 1 over 16. And next, we want to move it to get a positive exponent, so we get 1 over negative 2 to the fifth. We'll figure out what negative 2 to the fifth power is, and we get 1 over negative 32. And then last but not least, you've got a negative 2 to the negative fifth without parentheses. So we've got 1, we'll put the negative out in front, 2 to the fifth, which is going to equal a negative 1 over 32. If you have a negative exponent on the bottom of a fraction, you flip the exponent to the top to make it positive. So the idea, in order to get rid of negative exponents, it has to cross that fraction bar, or it has to move from either the denominator to the numerator or numerator to the denominator. So here we want to simplify. We've got 7 over w to the negative fourth. Well, I've got my base is w, my exponent is a negative, so that means I want to move it underneath to make it positive. So my answer becomes 7 over w to the fourth power. That's it. In B, I've got k to the negative second underneath negative 5, but I want to make it a positive exponent, so I bring it up. So it's negative 5k squared. So we're moving the exponent in order to change its sign. All right, so C, we've got a to the 0, b to the negative second. Well, I know the b is going to move, so it has to become a positive b to the b squared, or the negative has to become a positive. And then we've got c to the negative third, d to the sixth. To make the 3 positive, we move it up. We should also recognize that a to the 0 power becomes 1. So as we simplify this, a to the 0 is 1. We have a c to the third, the b squared moved down, and then we have d to the sixth. And so this is our simplified expression. In D, we've got 2r to the 0, m to the negative third. The m to the negative third needs to move, so that way it becomes a positive third. And then the r to the 0 becomes 1, so 2 times 1 is 2. And we're left with 2 over m to the third. We want to evaluate expressions for the given value of the variables. Before we evaluate the expressions, we first want to simplify them or change them so we don't have negative exponents. So that means we'd have to move this underneath. So changing this, we get 1 over x squared. Then we're going to plug in 4 for x. So I've got 1 over 4 squared, which gives me 1/16. Same thing in question 2. We want to simplify negative 2a to the 0, b to the negative fourth. So I know that I'll get negative 2 stays. The a to the 0 becomes 1, so I don't have to worry about it. And the b to the fourth goes underneath. So it becomes a positive 4. Now I'm just going to plug in my value for b. So negative 2 over negative 3 to the fourth power. Well, when I multiply all that out, I get negative 2 over 81, and I can leave my fraction like that. Example 3, 3r to the third, t to the negative second. I'm going to have to move the t to the negative second to make the exponent positive. So I'm going to get 3r to the third over t squared. And so I plug in my values. So 3 times 2 to the third over negative 3 squared. I'm plugging in 2 for r and negative 3 for t, and I will just evaluate this as I see fit. So this is going to be 3 times 8, which is 24, over 9, which we can reduce down to 8/3. And that's my answer. So remember, when you're trying to simplify negative exponents, you have to move them across the fraction bar, or you're moving them from the denominator to the numerator, or the numerator to the denominator in order to make the exponent positive. We do not want negative exponents in our problems.